can start. So read it, huh? Monica, please read.
Can give a message in Messenger.
Yeah, I just gave the message to them, all of them. Yeah, I already gave the message. Yeah, read. Monica, read.
Number two,
Hmm.
figure 2.1.
Hmm.
Shows a large container ship traveling at consistent speed. Speed of the ship is 9.7 meter per second. Calculate the work done against the resistive force on the ship in 1 second.
Mhm. So in this question we have speed, right? Calculate the work done against the resistive force on the ship in 1 second. We have time. Then we have resistive force 2.8 into 10 to the power 6 Newton. That means we have force, we have time, then we have speed. So how can we find the work done? Work done equals force into distance moved, right? Hello?
Yes, sir.
Yes, sir.
Yeah. So if you want to get the, you know, work done here, so how can you find it? Any idea? Any idea you have? So how can you find from this information the distance moved?
Sir, 9.7 meter per second.
Yeah, 9.7 meter per second. They are saying us work done against the resistive force on the ship in 1 second. So we have the distance moved in 1 second, right? 9.7 meter, right?
Yes, sir.
So we have 9.7 meter per second here, 9.7 meter in 1 second. So if we multiply 9.7 with this one, the given force, resistive force, then we'll get the work done in 1 second. Okay. So,
Oh, okay, sir.
so you multiply the force into distance moved in 1 second.
Sir, can you explain again why do we need to multiply those two?
Yeah, sure. Uh, this one is given speed of the ship 9.7 meter per second. Okay, per second means what? 1 second.
1 second.
1 second. So 9.7 meter in 1 second. They are saying. So we are having here meter. Meter means distance moved, isn't it?
Yes, sir.
So in 1 second, the distance moved is 9.7 meter.
Yes, sir.
So we have here force into distance moved in 1 second. If we multiply force and distance moved, then we are getting work done in 1 second. Is it clear?
Okay, sir. Yes, sir. Understood.
Okay, do it please. All of you do it, then check what's the answer is coming.
2.7 times 10 to the power 7.
2.7 times 10 to the power 7 joules, right? Good, good, very good.
Sir, 2716, then four zeros.
Again say,
2716, then four zeros.
okay, let us write it, then we'll understand. 2, 7, right?
Yes, sir. 16.
1, 6,
Four zeros. Yes, sir.
multiplied 1, 2, 3, 4, 5, 6, 7. 10 to the power 7, right? It's all the same, right? What Monica said, the same answer. She said in power and you said in like full form, right? Without making power. So it's matching, right? Both the answers are matching.
Sir,
Mhm.
the 16 goes away. That doesn't matter.
That doesn't matter for two significant figures. We are writing the answer in two significant figures.
Okay, sir.
Hmm. Or you can write in three significant figures like this, 2.72. Okay. It's the courtesy, or it's the uh, tendency, or it is the heritage that we have to write the answer in either two or three significant figures. Is it clear? Hello?
Yes, sir.
Okay, done. Or this part is done. A1, then
Done, sir.
yeah, A2 we can go. A2, the answer you see what's coming. Yeah, read it, please. Maibuna, read.
The engines are powered by oil. State the energy transfer that is taking place when the ship is traveling at constant speed.
So, what is the energy transfer process? Like in
Chemical energy to heat energy?
yes, chemical energy to heat energy, then kinetic energy. Three steps, right?
Yes.
Okay, so you write it, chemical energy to heat energy, and then kinetic energy, because they are saying it's traveling at constant speed, so it is now in kinetic energy, the last step. Yeah,
Done, sir.
next. Yeah, continue next.
The mass of the ship is 2.2 into 10 to the power 8 kg. The engines are switched off and the resistive force um, causes the ship to decelerate. Calculate the initial deceleration of the ship.
Yeah, what is the initial deceleration? How can we calculate deceleration? Deceleration and acceleration are say same thing, right?
Yes,
Hello.
sir.
So deceleration is negative acceleration. We will use the same formula what we use for calculating acceleration. So we have here mass, and we are asked to find the acceleration or deceleration. Then which formula we should use? F equals ma, right? F equals ma, that formula, because we have already resistive force given at the top, just after the figure 2.1. You see the resistive force acting on the ship is 2.8, right? Into
Yes, sir.
10 to the power 6. So it is force. Force is given and mass is given. We can
Sir,
calculate
what
the
is the resistive force?
resistive force, like if anything is moving, um, it's maybe on the ground or it's on the water, anywhere, it's facing some opposing force of motion, right? Hello.
Yes, sir.
So that opposing force is giving you the resistive force.
Okay, sir.
So this resistive force is the cause for deceleration, right? Isn't it?
Yes, sir.
That's why we have to find the deceleration from this information. The resistive force is given, the mass is given also. So calculate it, huh? Then tell me what's your answer.
Sir, what formula?
F equals ma. F equals ma. This one. We get this formula in dynamics, topic 4, dynamics, right? Oh, you don't know this formula?
So we weren't there in those class. Like we missed them.
Okay, so this is the formula. This is also, you write it, no problem, no problem. You write F equals ma. This is Newton's second law, and
Okay,
here
sir.
the law is stating that uh, force, resultant force, is the product of mass and acceleration of an object. The acceleration will be in the direction of resultant force. You write, I'm writing. You write here F equals ma, Newton's second law. Huh? Newton's. Monica,
Yes, sir.
you also write, huh? Newton's second law. So it is in dynamics. Huh? Topic 3, dynamics. Topic 3, dynamics. When we will do it, you will get it, huh? No problem.
Okay, sir.
Topic 3, dynamics. Then uh, the statement of this law is resultant force working on an object is the of mass the direction of acceleration is in the direction of resultant force. Are you seeing, all of you?
Yes, sir.
The resultant force working on an object is the product of mass and acceleration. The direction of resultant force is in the direction of resultant force. Have you written? Hello?
Yes, sir,
Yes.
done.
All of you wrote. So what you wrote, can you say? What you wrote? Could you please say again? Hello?
The resultant force working on an object is the product of mass and acceleration. The direction of acceleration is in the direction of resultant force.
Okay, very good. Thank you so much. So you understood it now, right? How F equals ma is working. So
Yes.
we are going to find deceleration. That one is coming like this. Acceleration is similar to deceleration. Deceleration means slowing down, acceleration means speed up. So deceleration is negative acceleration, okay? So A equals F by M. F is given here 2.8 into 10 to the power 6 and mass is given 2.2 into 10 to the power 8. Put both the values and get the answer. What is the answer? Check please. You got the answer?
The answer is huge.
It's huge. Huh?
Yep.
Yeah, what's your answer?
Sir, the answer is very big.
It's very big. How it is very
Hmm.
big? You got F by M, right? 2.8, then multiplied 10 to the power 6, right?
Yes, sir.
10 power 6, okay. Then we have
Divided by
2.2,
into 10 to the power 8.
10 power 8. 8. So it comes 2.8 by 2.2. How much?
1.2 times 10 to the power 22.
No, no, no. You just tell me 2.8 divided by 2.2. This much only. How much it comes? 2.8 divided by 2.2.
1.273.
1.273. Very good. So we have 10 to the power 6 and 10 to the power 8, right? That means I show you a simple way to do it. Huh? Even you do not need calculator. We have here 10 to the power 6, right? The power, only power thing I'm writing here, 10 to the power 8.
6
So
and 8.
yeah, so if you have like this, then 10 to the power 6 and 10 to the power 8, they will be divided, right? There is power, so 10 to the power 6 and 10 to the power 6 can be cut. And we have only left 1 by 10 to the power 2. Do you know this in maths?
Yes, sir.
So 1 by 10 square. 1 by 10 square means what? 1 by 100.
Yes, sir.
So you are getting here 1 by 100 only, right? 1 by 100 means you have to divide this value with 100. So do it. 1. So here we get 1 by 100.
So 0.01273.
Yes. So you write that 0.01273. That means it's coming 0.013, right? If you write in two significant figures, isn't it? It's coming 0.013 meter per second square.
Sir, how did we get 2 to the power 10 to the power 2?
Oh, this one, like index calculation. This is actually basic maths.
Yes, sir. If we cut it by 2, we get 3 by 4.
Yeah, I am showing you. It's very simple to get. Look, uh, it's working like this. I am writing here in the left side. In the power of the 10 is added, right? And subtracted. So you can write it as 10 to the power 10 power 6, then 10 power 6 times 10 square. Do you know this?
Oh, okay, sir.
And 10 to the power 6 and 10 to the power 6 can be cut. Now you understood?
Yes, sir.
Okay, great. Monica, have you understood it?
I didn't understand the square part. I
Which
mean the
one?
power part. The
Power
power
one.
about, yes, sir.
Okay, look here. 10 power 6 I wrote here. Then 10 power 8 I wrote here. You understand it? This is all right?
Yes, sir.
Okay. And the other part is coming 2.8 by 2.2 is coming 1.273. So this part 10 to the power 6 I wrote. Is it all right?
Yes, sir.
Then 10 to the power 8, like index form, how it works, the power we should add them, like 10 to the power 6 and 10 to the power 2. If you add the power, it comes 6 plus 2, it is 8. Have you understood now?
Yes, sir.
So we have
Like
here,
in down,
yeah, in down we are multiplying, like 10 to the power 6, we can write this way, 10 to the power 3, like 10 to the power 3 times 10 to the power 3. Okay, how it works, I'm showing you. That means 10 to the power 3 and 10 to the power 3 makes 10 to the power 6. Is it clear now? Hello? Index form,
Sir,
you
but
got?
the answer
yes,
will be 0.01273.
Yes, 0.01273. If you write in two significant figures like this 273, you can write in 3, right? Is it clear? Like I'm writing the whole thing you told me, 0.01, 2, okay, 273, right? This way, isn't it? Hello?
yes, sir.
Yeah, Maimuna, this way, right? As you said, hello?
Both of them left.
Oh, they may be disconnected somehow. Okay, so it's 0.01273. That means in two significant figures, it comes, if you round up, it comes 0.013. You understood it, right, Monica?
Yes, sir.
And the power thing you understood?
Sir, explain me why did we use 1.273 times 1 out of 100?
Yeah,
Why did we use
that's
1
that.
out of 100?
Yeah, very good. Look here, we have here this power left, right? 10 to the power 6 and 10 to the power 8. Okay, this one is left, right?
Yes, sir.
Other than 1.273, we have this one left. So if we calculate it, it comes like this, 1 by 10 square or 1 by 100. 10 square means 100, right? Hello?
Yes,
If
sir.
you press in calculator also, it comes like this. You take, if you do this 10 to the power 6 by 10 to the power 8, then it comes 1 by 100 or 0.001. 0.01. Take in calculator.
Yes, sir.
So
Yes,
you
sir.
understood it now? How it is 1 by 10 square or
Yes.
1 by 100?
Yep.
Hello?
Yes, sir.
Yeah, I think in class 6, you got this index form calculation, right? Standard form
Yes, sir.
in maths, how to calculate like power of 10, 10 to the power 6, 10 to the power 8, you have to make 10 to the power 8. And this way you can calculate. I think you can recall now, right? Yeah, so this part is over, right? You understood? Hello?
Yes, sir.
Okay, thank you. Now,
Mm-hmm.
where is those two girls? Maybe they disconnected. Let me write in the group. as they both together disconnected, maybe their electricity went. They are sisters.
Oh, yeah.
Yeah. So till B1 we did. Now B2, part B2. Yeah. Can you read this?
As the speed of the ship decreases, its deceleration changes. 1. Suggest and explain how the deceleration changes.
Yeah. How the deceleration is changing. Like if you run or walk, uh, like if you run, then you understand it. Have you ever run in your life? Hello?
Of course.
Of course, yeah. Of course
Yes,
you
sir.
run. Of course you run. And when you run, you can remember that you are feeling air is opposing your motion, right?
Yes, sir.
That means uh, if you increase your speed, then you are also facing some resistive force from air. The more you have the speed, the more the resistive force, isn't it? Hello?
Yes, sir.
The same thing is happening for the water and ship. As the speed of the ship is decreasing, the resistive force from the water is also decreasing. That's why the deceleration also
Mhm.
decreasing. Is it clear? Is it clear to
Yes,
you?
sir.
So you write it here.
Yes, sir.
What you understood, you write it here. As the speed of the ship decreases, the resistive force of water also decreases. As the speed of the ship decreases, the resistive force of water also decreases, right? That's why
Yes, sir.
deceleration, that's why deceleration also decreases. That's why deceleration decreases as well. If you think that similar word is making boring your life, so you can write deceleration uh, decreases as well. Okay.
Yes, sir.
Okay, so two. Then other part we will discuss in our next class. As they are absent, they need to get this, the graph one, how to draw the graph. Okay.
Okay, sir.
Okay. Thank you so much for joining and taking part in the discussion. Stay blessed. Allah Hafiz.
Allah Hafiz.